Hello guys, today I want to show you how you can take the derivative of x to the x. So this is pretty simple, and the method that we're going to use today is implicit differentiation. So let me show you what you can do. You're going to define a variable that, well, you can call it anything that you want. I'm going to call it y, and y is going to be equal to x to the x, okay? Now something you can do, and this is basically going to be a combination of implicit and logarithmic differentiation. You can say that the natural log of y is going to be equal to the natural log of x to the x, okay? And well, you know that there is a property of logarithms that basically tells us that the log of log a of x to the n is going to be equal to n, so you can bring the power to the front of log base a of x, okay? In this case, a equals e and n equals x. So we can move x to the front, and we can have something like x times ln x, okay? So we have this, you can just simply move this x to the front. And now this is pretty good because now you can grab these two expressions and you can take the derivative of on both sides, okay? So you're going to have something like this. You're going to have the derivative with respect to x of ln y is going to be equal to the derivative with respect to x of x times ln x. Okay, this is how much you get. And now we're going to use implicit differentiation. So what we get is the following. We want to take the derivative with respect to y of ln y times the derivative of y with respect to x, okay? And we know this would be equal to, so for this derivative, we can use the product rule. So we know that the derivative of x is going to be 1, and we're going to multiply that by ln x, and yeah, so this should be a 1 times ln x plus. Now we want to leave x the same, and we want to take the derivative of ln x, which we know is going to be 1 over x, okay? And now we can just simply solve for dy over dx, and that is going to be how we can use implicit differentiation to solve for this derivative. So let's do that. We know that we're going to have, first, this derivative is going to be equal to, I'm going to continue over here, and then I'm going to move down there. So we have 1 over y is going to be equal to dy over dx, and this is equal to ln x plus this would be equal 1. This would be equal to 1, okay? Nice. And now we know that y, I'm actually going to solve for dy over dx, and then we can substitute y. So we know that dy over dx would be equal to y times ln x plus 1, okay? This is how much you get. And now we know that this would be the implicit solution. In math, this is what you call the implicit solution, because you do not have dy over dx only in terms of x. You also have y in there, okay? So implicitly, you know that y is a function of x, and somehow if you plug in y in terms of x, you're going to get a function that is only in terms of x. And well, in this case, we do know how much y is. We know that y is equal to x to the x. So we can simply substitute that, and we're going to have that this derivative, x to the x, is going to be equal to x to the x times ln x plus 1, okay? And this is equal to the derivative of x to the x using implicit differentiation, okay? So I hope you enjoyed this video, you learned something, and see you in the following one. Bye!